Hello everyone, welcome back to Calculus BC. We're going to review all things Unit 6. We're going to look at this beautiful picture. We're going to find the area of the shaded region. We're going to use cross sections. We're going to find the cross section of these four shapes of this region. We're going to then find the volume using the washer disk method and the shell method. So everything is going to be done with this picture. So for area, all you're going to do is remember we're going to integrate from A to B, and it's going to be the top function, which is going to be f of x, and we're going to subtract the bottom function, g of x, and then we're going to do dx. This is all that we do for area. Awesome, fantastic. I put these two together because for cross sections, what you're going to do is you're going to also integrate from A to B. And you're going to do f of x minus g of x. And you're going to quantity square that, dx. And then you're going to have some value of k. Some value k over here. And so cross section, you're going to take the top function. You're going to subtract the bottom function. Quantity square both of them, that difference. And the k value. If it's a square, your k value is simply going to be 1. If it's an isosceles right triangle, your k value is going to be 1/2. If it's an equilateral triangle, your k value is going to be the square root of 3/4. If it's a semicircle, your k value is going to be pi/8. So if I asked you guys to find the cross section of this picture, and I wanted you to use semicircles, then you would literally put a pi/8 and then the integration of a to b of f of x minus g of x, quantity squared. So that is pretty straightforward when it comes to simply area and cross sections. Just be careful that cross sections, you will subtract them together, but you will then square the quantity. This, there's no squaring, it's straightforward. Okay, so now we're going to find the volume rotating around the x-axis, y equals 3, and then the y-axis. And I'm going to go ahead and just let's say that y equals 3 is right here. So y equals 3 is here. So let's look at the x-axis first. So the x-axis we're actually going to use, the washer disk method. And so we do ourselves a little rectangle, and it's flush. It's actually flush on our curve. So for volume, if we want to use the washer disk method, the first thing is that we can go ahead and pull out a pi. Then we're going to integrate from A to B. And then I went ahead and put the rectangle right here for us. So it's going to be our top function minus our bottom function. And again, this will be f of x minus g of x. And then we're going to square it. So this is basically going to be, now I know you're thinking, okay, this looks really similar to our cross section. That is absolutely true. That's absolutely true. And again, volume of washers is cross section. We're now looking at a circle. So circles k is going to be pi. Now, you guys are used to seeing this as a big R. If this had been big R, then you would say this is going to be the pi a b, then big R squared dx. So this is both the same function or same formula for this particular problem. So now if I want to do y equals 3, then again, I'm going to use my washer method. And so it's going to be, again, pi from A to B. Our big R is actually going to be the distance from our axis rotation all the way down to our function that's the furthest away. So in this particular example, it's going to be 3 minus g of x quantity squared. And I'm going to say that this is just g of x, right? Because it's going to be the function that's the highest minus the function that's the lowest. So our axis of rotation is again above the axis. So it's going to be 3 minus the curve that's the furthest away. And then we're going to do minus, and we're going to do the curve that's the closest to our axis of rotation. But again, it's going to be 3 minus f of x quantity squared. And so this is going to be how we're going to find this actual answer. And then the final example we're going to do, ladies and gentlemen, is for the y-axis. So rotate around the y-axis, and I think that this one's much easier to do the shell method because you only have to worry about one thing. So we're going to go ahead and pull out a 2 pi. We're still going to integrate from a to b because everything's given in terms of x here. So if we did wash or disk method, we'd have to worry about figuring out how to rewrite this in terms of y. We can't do that. So a to b. Now remember that our radius is going to be, well, first of all, our distance here is going to be x. Because remember, we always do our distance from our axis, our y-axis, to our rectangle. So that's always going to be x or y based on what our shell method we're going to use. But in this particular example, our radius is actually going to be equal to x because what we want to know is the distance from our axis of rotation to our actual rectangle. And this actually ends up being x because our axis of rotation is y. So this is going to be x, and then our height is going to be f of x minus g of x dx. And so this is how we're going to use our shell method. We're going to do one more example, which is going to be x equals 5. So I'm going to go ahead and do that. And so we want to rotate, and let's pretend like the line x equals 5 is right here. And we want to find the volume of that. So again, shell method is the best way of doing the problem because it's parallel to our axis. So we're going to go ahead and do 2 pi. And we're going to integrate that from a to b. And so now I left this technically correct. So this is going to be x. Our radius is going to be this distance. So I'm going to show you guys the difference with this. So the radius is going to be from the axis of rotation to our rectangle. So the x is going to be from the y or x axis to our rectangle. The radius is from our rectangle to our axis of rotation. And so when we were on the y-axis, they were the same thing. But here it's not. So if I'm going to find the radius of this, well, I can say that x plus r is equal to 5. And so the radius will be equal to 5 minus x. So my radius is going to be 5 minus x. And remember, like I've said, the actual lesson of shells, that our height is going to always be the same with respect to x. So those are all the setups that you guys can do for these problems. So I hope that somewhat helps solidify, summarizes everything for you, and I will see you guys in the next lesson. Take care.